Today I'll be teaching you how to turn an edge list into a matrix, which is arguably the hardest step here and the one that has the most pitfalls. So an edge list is basically a regular spreadsheet with at least three columns: head, tail, and value. Head is the originating node and tail is the receiving node for any given edge, and each row in the data set represents an edge that's going to appear in our data set. So if we look at our sample data and pull out all the participant IDs from both head and tail, what we get is what will become our node labels, which are basically a list of all the participants in our study. And we're going to need this for a couple of reasons later on. First is to create the matrix. So the matrix is to be n by n, which means that it should be square with as many rows and columns as there are unique participants in the study. So here I've set up an example matrix using the node labels earlier. I saw there were 10 of them, so I created a 10 by 10 blank matrix. So just a brief explainer, how does matrix indexing work in R? This X variable I just created here, I'm going to use as what is called index values. And index values can access any element in an R object. So in this case, I highlighted the rows here with the value row by accessing the row index of the matrix shell variable here. So here's the same thing, except accessing columns. And so you can see earlier I had the X variable here, now X is here, so that I access every other column instead of every other row. And we're going to use this to basically map our values into and out of the matrix at will. And part of this is going to be using the which command, and which accesses all of the index values that meet the specified criteria. So we're going to use this to basically first map our node labels onto our matrix. Then we can use which to identify the head and tail values that correspond to any given row in the edge list. So what I did here is take a sample row out of our edge list with a head value of I3 and a tail value of I2. Then I checked those node labels against the node labels in the matrix to get their x and y coordinates. Then I map those x and y coordinates onto the matrix to create the 0 value you see here. And this is just a little explainer kind of showing what happened. So this function basically does the same thing, except instead of mapping the values directly into the matrix, what we're going to do is actually write those coordinates back onto the original edge list. And this step is a little unnecessary, but I think it's necessary because it creates a paper trail back to your edge list so that if you make any mistakes later on, you can find out what happened by checking the matrix errors against any edge list errors. So maybe you're missing coordinates or something like that. So if we iterate this function over each row of the edge list, what we end up with is our blank matrix shell is now populated by the original values of the edge list. And you can see here there are a lot of blank values, or NA, missing. And those are treated the same as zeros in an analysis. So if your edge list has missing rows, it's not a problem. As long as you, as your node labels meet some specified criteria I'll talk about later, this process should go fine. You just want to make sure that your node labels are accurate, your matrix is square, and that you're doing some kind of error checking along the way. So now our data are in class matrix, which is going to be really important because all of the major network analysis packages are going to expect it to take a matrix, and so if you give them an edge list, they're not going to know what to do with it, generally speaking. So again, the dimension names of the matrix, x values go here, y values go here, and we're going to use these node labels later on to bring in extra data to kind of enhance our visualization so that we'll be able to identify nodes or edges that we want to highlight and highlight those a different color, make them a different size, and do other things with our network plots to make them more informative. Stop recording iOS.